So this video is actually quite important because it tries to address the question, how do Java thread interrupts differ from more traditional hardware and operating system interrupts, which you may have learned about if you've taken an operating systems course or done any systems programming. So we'll kind of talk about, compare and contrast these different things. So interrupts at the hardware or operating system level have several interesting properties, which you can read about if you read the interrupt Wikipedia link or the Unix signal interrupt link. First of all, these interrupts are typically asynchronous. That means they can occur anytime. And they're also independent of the instruction that's currently running. So if you're in the middle of doing something and a hardware interrupt occurs, then usually whatever you're doing is paused and the interrupt handler gets a chance to run. And that same thing is true for traditional software interrupts at the operating system level. Something else to note is that the programs don't actually have to test for these interrupts explicitly because they're handled out of band, right? You're just running along, doing your own thing. Boom, somebody stomps on you, suspends you, interrupt handler runs, then it stops and you're up and doing your thing again. But you don't have to actually check in the code that you're writing because the interrupt handler is going to be doing the checking for you. They're also preemptive. What that means is that the current thread of execution is paused while the interrupt handler runs, and then after the interrupt handler is done, whatever was paused can keep going. So those are the two of the key characteristics for hardware and operating system interrupts. Here's a very simple example. This is using the Unix SIGINT signal, which is an asynchronous interrupt. And as you can see here, this interrupt will occur asynchronously. It preempts the current instruction, and you don't have to test for it explicitly. Here's the code. We have this program. This is a Unix systems program where it goes ahead and sets up a signal handler for SIGINT. Here's the signal handler. Here's SIGINT. And it then goes ahead and goes to sleep for 10 seconds. While it's sleeping, you could sit there and type Control-C if you're running in Unix. I think that'll also work in a Windows shell too. And that sends the SIGINT interrupt to the program, and that goes ahead and causes the signal handler to be called back. Notice you're not testing for this in this loop anywhere, and then it goes ahead and prints out, I got SIGINT, if it got SIGINT. And then it'll typically shut the program down too. Asynchronous and preemptive interrupt handling is the way people do it at the operating system and OS level, at the hardware level. However, it's very hard to reason about your programs that are written this way. It's really complicated. For one thing, you can have race conditions occur because stuff's kind of appearing out of thin air, and you may not be in a position to protect against it. There are issues with the reentrancy. If you have an interrupt handler, and that interrupt handler makes changes to state or makes calls to other functions that change the state, the code that was interrupted might have been in the middle of doing something, and it may have its data structures in some sort of inconsistent order, not expecting it was going to be interrupted. And then the next thing you know, an interrupt occurs, the interrupt handler does something, and it corrupts the state of the program. I'm sure you've all had experiences before where you're like studying for a test or you're busy, and then someone comes and interrupts you. And then you're like, go back there, you're like, where was I? What was I doing? You'll kind of lose your train of thought. So that's an example of reentrancy. And then there's also problems with what are known as non-transparent restarts. So if you are in the middle of reading some chunks of data and an interrupt occurs, then for certain kinds of I/O channels, it won't know where to restart. Sometimes it can restart where it was. Other times it's just like, oh, well, I don't know what was going on. You may have run into this kind of problem before if you're trying to transfer a large file, and for whatever reason, the network gets disconnected or your program crashes or whatnot. And then when you restart, you're like, it says, oh, let's restart from the beginning, which is very annoying because you'd like to pick up where you left off. So those are examples of non-transparent restarts. Having said all of these things about hardware and operating system interrupts, Java thread interrupts are completely different from all this stuff. And this is a source of never-ending confusion because people see the word interrupt and they think, oh, a Java interrupt just is like a hardware interrupt. It's asynchronous, it's preemptive, or a Unix signal, it's preemptive, it's asynchronous. No. Delivery of a Java thread interrupt is synchronous and non-preemptive rather than asynchronous and preemptive. In other words, handling and delivery of these interrupts doesn't occur at arbitrary points. You actually have to test for them. and they don't pause and later resume code that's currently running. You, the person writing the code, have to check for them explicitly and then handle them in some way. So as we talked about before, in Java, you have to check to see if you've been interrupted and then do something, like throw an interrupted exception or whatever. And so what's happening there is that you're checking for interrupts synchronously, and you're handling interrupts synchronously by throwing an exception or restarting or whatever you're going to do, right? All the different patterns we just talked about. So nothing is, the exceptions in Java threads are not asynchronous, and they are also not preemptive. You have to test for them explicitly. Oddly enough, and this is actually really frustrating, certain operations in Java cannot be interrupted. So if you block on I/O channels that are not interruptible, there's no freaking way of interrupting that code. And you can actually read about this. This bug has been known probably for 20 years or so. I think it's a bug. So here's an example where we have a program that's going to wait for someone to type something in on the command line. So this is a console app that's going to wait for someone to type something in. So you can see it says system.in.read. OK, so far so good. You might use this for a test program to say, you know, please hit return to continue. You've probably written code like that before. Unfortunately, there's no way to interrupt this code. You can't hit Control-C. You can't do anything to get the thing to wake up because you can't interrupt read calls on the console, which is very bizarre. OK, so that's the end of the discussion of Java threads. There's also another topic we could talk about, which is an example illustrating this stuff. But I think I've shown you plenty of examples now, so hopefully you understand how this works.